About 3 months ago, I bought a 150-pound CRS Catalyst Express medical robot arm. This arm is about 20 years old and was originally used in a lab environment for moving samples around. A liquidation company acquired it and sold it through Facebook Marketplace. To me. Oh man, you can find some fun stuff on Facebook Marketplace. Initially, I tried to get the robot arm to run off the software that it originally came with. From what I could tell, the robot arms were usually shipped with a computer pre-installed with software that was connected directly to that individual robot. I started by reaching out to the manufacturer to see if they could send me this software. They politely told me to pound sand. I then scoured the internet for any mention of this robot and was able to find a couple of pieces of literature about it. Two of these were user guides, and one was a research paper on a holistic approach to co-current engineering and its application to robotics. It was just as confusing of a read as the title would suggest, and it made me feel dumb. I'll link it in the description in case you're interested. The user guides, on the other hand, were quite useful and gave me a better idea of what software I would need to run the robot. I also tried getting help from a couple of Indian guys on Fiverr, but that was ultimately a fruitless attempt. As I sat there watching and rewatching the one video of this robot that I could find, I remembered my dark horse, the ace up my sleeve, the power card that has never failed me, Reddit. I carefully crafted a beautiful post begging, nay, praying for help finding this software, and help came. And I then decided to start talking to inanimate objects in hopes that they would be more encouraging. I gave up getting the stock electronics to work and started taking the robot apart to see what I was dealing with. Once disassembled, I found that the arm was being moved by 5 large gear-down DC motors. This was surprising, as I expected something more along the lines of a stepper motor, such as those used on 3D printers. The motors in the robot were connected to optical encoders that give feedback to the robot's brain. They do this by using a metal disc with thin slots cut into it to disrupt the light flow between an LED and a light sensor, thus outputting specific signals that can be interpreted and used to get a very accurate measurement for both speed and direction of rotation. The result is something similar to a hobbyist stepper motor, except that this motor can rotate multiple times. I'd give more specifics on how encoders work, but it's a bit out of the scope of this video, and more importantly, I don't know what I'm talking about. I briefly pursued the idea of using a 10-turn potentiometer instead of the encoders to simplify things, but decided against it because I ran into complications integrating them, as well as concerns about their accuracy. As a side note, each of the joints have an electromagnetic brake that locks the joint in place until a voltage is applied to the brake. It's a safety feature, but also makes the arm much more useful for holding stuff when it's powered off. My next goal was to figure out how to power on one of these motors. Well, that was easy. Now I needed to figure out how to electronically switch between running the motors forwards and running them backwards, while also being able to control the current applied to the motors, thus controlling the torque. The solution that I eventually came up with was building an H-bridge. What this does is it uses a series of MOSFET transistors to funnel the electricity down certain paths so that it flows through the motor in the desired direction. Super cool circuit, but long story short, I ended up not being successful in anything but burning up a bunch of MOSFETs. Alas. Only after I got some off-the-shelf motor controllers did I realize that I needed to be using 2 different types of MOSFETs instead of just the one that I had been using. I'm glad I bought the motor controllers. Oh, sounds like my green screen is here. Let's go get that. Hopefully that'll work. As an input for the robot, I decided to use a circuit board that I had made for some previous projects. It pops right into an Xbox 360 remote and allows me to use the controller knobs and buttons as inputs for the robot. I can even put an Arduino Nano straight into the controller to minimize wiring. Let me know in the comments if this is something you'd be interested in using in some of your projects. Initially, I decided to be objectively lazy and use a separate Arduino to process inputs and output a signal to its own motor controller, which then outputs a power. This is such a convoluted. This mostly worked, and I was able to get the robot arm to move using the controller. I then tried to set up a master Arduino to control each of the 5 slave Arduinos in order to fix some of the issues such as squealing motors. Turns out this is much easier said than done. Anyway, I ended up pivoting to using a single giant Arduino with about a bazillion pins instead of the 20 or so pins that each of the 5 smaller Arduinos had on them. Although I had to mostly start the code all over, this ended up being a much better long-term solution. It fixed the buzzing motor sound and also makes it way easier to make code changes in the future. Fun fact, I actually don't know how to code, but was able to struggle my way through it by very gradually building up and modifying the code with the help of ChatGPT. This made it so that I had to regularly start the code over from scratch because I don't fundamentally understand it. I think I learned a fair bit about the basics of coding using this process though, and I'm just happy to have been able to complete the coding that I needed to. As an overview, when a knob is moved on the Xbox controller, the Arduino receives a voltage signal to one of its analog pins. It interprets this signal and applies a voltage to the corresponding digital pin, which is connected to the motor controller, which is then wired to a gear down motor on the robot arm, resulting in one of the joints moving. Now let's put the robot arm to the test in a high accuracy painting battle.
Yeah, I'll get it.
Okay, did you want your thing?
What's that?
All right, so for mine, I'm going to be, who knows, it might be the new way to do art. Oh no. Oh, this is like way harder than I know. Don't ever touch the rotating head. Like, that's just all around a bad idea. I don't know why I'm the one giving suggestions, as I haven't even managed to get the robot in the paint yet. It's a really intuitive control system, I'm telling you.
There is paint on the canvas.
Okay, we're just gonna... Oh, shoot. Son of a gun. Oh, rotate back up. It's all over my desk.
The fact that it's constantly sagging doesn't help either. Oh dear.
No, I pressed it. Oh. Oh my goodness, this is more touchy than my last girlfriend. Come on, get the green. Got some green. The first natural green. And a little bit of blue.
Way too many axes controlled counterintuitively.
Come on, little buddy. You are functional. Prove it to the internet. Come on.
Oh. Too bad your paintbrushes suck.
Yeah, that's the core issue here, clearly. Oh! Come on! You can do it! I believe in you! I mean, it's not really going uphill from here. So we might cut our losses and...
I think we wiggled some bolts free.
I'm getting evicted!
My dad's gonna kill me. And they're completely opposite of what you would expect.
Yeah. The up and down is like swivel up and down, so it rotates 360 while swiveling up and down.
Counterintuitive. Ooh.
Ah!
There we go. We decided that our robot was too sophisticated, and so, and it's gonna work. It's gonna work.
Our robot. This is cool.
I need my reference image.
Oh, my bad. Hold on. Oh dear. Ah! Oh dear.
She's got the power! Made by man, by machine.
by man and machine
Together.
and a robot.
There's a couple of improvements I'd like to make to this robot. But before I get to them, I have a few things to say. I'm actually pretty surprised that I was able to get the robot arm to work at all. It was definitely quite a challenge and well beyond any robotics that I've done before. I want to encourage you to attempt a project that you're not quite sure will be successful as well. Anyway, besides some of the obvious quality of life improvements, such as increasing the length of some of the wires, the main thing I'd like to work on is getting the encoders working. This would make the arm quite a bit more useful, as it would allow me to move the arm more precisely. This would allow the arm to be used for something such as 3D printing or alongside a computer vision system. Consider subscribing or leaving project recommendations in the comments. Thanks for joining me.